Okay, this is going to be the third video on how to find the derivative of an inverse function at some given value of x, and you're given the original function. Now, first of all, in the previous videos, if you look in your book, and we also developed this in the past two videos, you should find this formula. Let's just kind of run through it. It says that the derivative of an inverse function at its value of x is equal to the reciprocal, or 1 over, the derivative of the original function at its value of x. And it also could be expressed in this form because the x value of the original function is the same thing as the y value of the inverse function. You could also write it as 1 over the derivative of the original function at y sub I. So again, the y value of the inverse is the same thing as the x value of the original. And that's where these formulas come from. Now, what the problems look like is this, it'll give you some kind of a problem. In this case, we've got f of x is equal to x cubed plus x minus 3. And it asks you to find the derivative of the inverse function. And usually you'll see it a couple of different ways. And we'll actually work this two different ways in this video. Now, the first possibility, if you're lucky, the problem will say like this. It'll say, find the derivative of the inverse, and it actually gives you the point 7 and 2. So what this is, we'll go ahead and write this right here, is it gave you the x value of the inverse, which was 7, and luckily, it also gave you the y value of the inverse, which is 2. So what this means is if you actually plot this point, if you go over to 7 and up to 2, you've got a point right here. This is the point 7 and 2, and what this is, it's the x value of the inverse and the y value of the inverse. So if you're lucky, you get both the x and y value of the inverse, and if that's the case, you're good to go. It's just really a matter of you've got everything you need. It's just a matter of plugging these points into this function, and that's it. So again, if you're given the original function and the x and the y value of the inverse, plug them into the formula, and that's it. So let's go ahead and we'll try that right here. So we'll scoot down and just look at what the formulas look like, and we'll just run through this thing. So I'm going to move it down just a little bit here. Now what the formula says is this, and we'll go ahead and write it one more time. It says that the derivative of the inverse function at its value of x, which is 7, so I want to find the derivative when x is equal to 7. So the derivative of the inverse at x is equal to 7 is equal to 1 over the derivative of the original function at its value of x, or y sub I, which in y sub I would be 2, 2. So you can say this, that the derivative of the inverse function at x sub I is equal to 1 over the derivative of the original function at y sub I. So using this version right here. So let's go ahead and run through that, and you'll see it actually makes a pretty easy solution. So first of all, here's what you need. You need the derivative of the original function. So you want to find f prime of x is equal to, and just take the derivative of the original function, which was x cubed plus x. So that derivative is going to be 3x squared plus 1. So the derivative of the original function was 3x squared plus 1. Okay, we'll scoot it down just a little bit more. Okay, now you want that derivative evaluated at 2. So evaluate the derivative at 2, and you would have 3 times 2 squared plus 1. So this means that the derivative of the original function evaluated at 2, that'd be 4 times 3, 12 plus 1. This would be 13. Now what this is the slope of the tangent line of the original function at x is equal to 2. Now what the formula says then is that you actually want to find the slope of the inverse function when x is equal to 7, and that's equal to 1 over this, so that's 1 over, and the derivative of this thing is 13, so it's equal to 1 over 13, and actually there's the answer right there. So the slope of the tangent line to the inverse function at x is equal to 7 is 1 over 13. So again, as long as it gives you the original function and both the x and the y value of the inverse, then it makes a really easy problem. Just plug it into the formula, you've got it. Now you don't have to do this, but just to make sure, I get some students who get this answer, or maybe you're a little bit unsure of what this answer actually is. So let's go back up to the graph and put a few things on here and show what this would look like. So here's what we know. If you have the x and y value of the inverse, because it's a reflection across a 45-degree line, for the original function, if the inverse was 7 and 2, the inverse will be over 2 and up 7, and you'd actually have a point right here. So over 2 and up 7, I've got this point. So this is the point 2 and 7, and what that is the x value of the original and the y value of the original. Now what you found when you did this problem was this, and we'll go ahead and put a tangent line on here. So I'll say it goes from here, and we'll just say down to about right here. So when you, in this problem, when you found it, and let's scoot down just a little bit and look at each part. When you found this part right here, the derivative of the original function evaluated with 2 is 13. That's the slope of the tangent line. So what you found was that f prime at 2 was equal to 13. And that is the slope of that tangent line right here. Now, to get this one, as far as the inverse goes, and let's real quickly run through this, to find the inverse of the original function, you would interchange the x's and the y's and solve for the new y. So if I made, this was y, if I made it be x, and we'll go ahead and put that right here. So x is equal to, and then the x's become y's, y cubed plus y minus 3. So this would represent the inverse, but the trouble is you can't explicitly express that in terms of y, so you really can't get a graph of it. Now, to get a quick graph, you can always do this with an inverse. The inverse is just a reflection of the original one across a 45-degree line. So let's pick a few points. Here's the first one right here. Second one, it goes right through here. The next one, the original one goes over 1 and down 1, so the inverse would have to go this way and up. I'd have to have a point right there. The next point I could get would be this point. This is the point 0, minus 3. So switch the x's and the y's, and you'd have minus 3, 0. And then finally, here's minus 1, minus 5. So this one would be minus 5, minus 1. And if I were to just draw a line, draw a rough graph through here, it would look something like this. It'll come up to here, goes over to here, and then continues on like this and goes through this point. So this is roughly what g of x would look like. So it's just the reflection across that line. Now, if the slope of this one was f prime and it was 13, let's also draw the slope here just to make sure you understand what you've got. So we'll go, say, from here and bring it over to about right here. What this is, here's a tangent line here, and this was g prime, so the slope of the derivative at x is equal to 7 was equal to 1 over 13. And that's what this answer is right here. So the slope of the original function was 13. The slope of the derivative is 1 over 13. And again, let's go back up and take a look at it. And that's what you're actually solving for. So in the problem, when it said find the derivative of the inverse at this point, that was the actual answer to the problem right there. And you found it by finding the slope of the original, then taking the inverse, and you got it. Now what this is all what you can do if it gives you x and y. So if it gave you both the x and the y point, you're lucky. But sometimes it does this. Rather than saying find the derivative of the inverse at the point 7 and 2, it'll just give you the x value, and the problem might be worded like this. So it'll just say at the point x is equal to 7. Now what that gives you is this. We'll come down here. You know that x sub I is equal to 7, but the problem is you don't know y sub I. And that's going to make things a little bit more difficult. You're going to have to do a little bit more work. So again, does the problem say, and we'll look back up here at this, does it give you the point and give you both the x and y value, or does it only give you the x value? So now, how do you solve the problem if you only knew the x value? And let's take a look at exactly the same thing. Now, we'll still go the same way about it. To do this, we're still going to need g prime is equal to 1 over f at y prime. So let's set up a couple things that we know. Now, right now, here's what you know. You know that x sub I is equal to 7. So if you came over here, and let's just put a little mark on the graph, I think I'll put it in red. You know that x sub I is equal to 7. But the trouble is, you don't know where y is. So, right, we'll put y sub I is equal to a question mark. Now, you also know this. If the x value of the inverse is 7, that's the same thing as the y value of the original. So you can go up, say, to about right here. here would be 7, and this is going to be the y value of the original. But the trouble is on this one, you don't know the x value of the original. So the y value of the inverse is the same thing as the x value of the original. So you can go across and you can kind of see it being here. Now, if you just looked at this thing, it looks like it would be somewhere around 2, but we'll do a little bit more work to actually come about that. So the question is, and we'll go ahead and drop this down a little bit, the original function was this. It is y sub o. The y value of the original is equal to this thing right here. So let's just go ahead and write that. I think I'll put it right here. I'll say the y value of the original is equal to the x value of the original cubed plus the x value of the original minus 3. So we'll start with this. Then we've got this. The y value of the original is the same thing as the x value of the inverse. So I'll replace that with this. So x value of the original plus x minus 3. But now I know the x value of the inverse, so this is equal to 7. So 7 is equal to x sub o cubed plus x sub o minus 3. So what this does, this gives you a way to find the x value of the original, which will be the same thing as the y value of the inverse. So if you can find the x value of the original, you'll have the y value of the inverse, and you'll have that. Now to solve this, it's a matter of if you've got a graph of the original, you can get an estimate of it from that. If you've got a calculator that will do the algebra for you, possibly you could put it on Solver and come up with that. But another way is just good old guess and check. So let's try that right here. So what I want to know is what value of x will make this true. So I'll just do a little guessing and checking here. So I'm going to guess, and we'll try this, that x is equal to 1. And this would be x sub o is equal to 1. Then I'd have, now to check and see if it's true. This would be 1 cubed plus 1 minus 3. Just plug it in and see if it works. Now, if you do this, this would be 1 plus 1, 2 minus 1. I get 7 is equal to a negative 1, which is not true. So I know that this is not right. X sub 0 is not equal to 1. So now I'll guess, and it's just a matter of guessing until you find one that works. Let's guess that x sub 0 is equal to 2. So I get 7 is equal to 2 cubed plus 2 minus 3. And if you do this, you would have 7 is equal to, and this would be 8 plus 2 would be 10 minus 3. 7 is equal to 7. That is true. So you know that x sub 0 is equal to 2. Now, if x sub 0 is equal to 2, you also know that y sub 0 is equal, y sub I is equal to 2. Because remember, again, x sub 0 is the same thing as y sub I. So now you know what y sub I is. So once you know y sub I, at that point, this problem is now exactly like this problem over here. So really, now that you know that y sub I is equal to 2, you can actually just move it over to right here and just repeat the process and you'll get the same answer. So really all it does is adds one extra step on this. So on this one, if it only gives you the x value of x, the x value of the inverse, then you can set the y value of the original equal to the x value of the inverse, and using a guess and check method, you can find out that x sub 0 is equal to 2, which is the same thing as y of the inverse. So this one would also be equal to 2. And then, once you've got that, then this problem is exactly the same as the previous problem, and you can solve it. So again, it's really just a matter of plugging. Once you know what xi and yi is, plug them into the formula, and you can solve and find the value of the inverse. But it also helps, I think, to have a sketch to get an idea of what you're solving for. So to find the derivative of the inverse is the slope of that black line right there. So to find the slope of this black line of the inverse function, you actually find the slope of this black line of the original function, and then since that was 13, the derivative of the inverse is the reciprocal, so it'd just be 1 over 13. So again, if you're lucky, let's go ahead and change this back again. If you're lucky, it gives you the point, and you've got both xi and yi. If you're not lucky, then it just gives you the x value, and you have to use this extra step to calculate the y value, which might include a guess and check thing. So there's one final example on how to find the derivative of an inverse function.